Welcome back. Now it's time for the second track, Batteries and Value Chain. We're excited to have a lot of amazing experts on our jury panel for this track. So please, jury, when you're posing your questions, please introduce yourself to the wonderful people coming up here. Thank you. Once again, we'll repeat the instructions. Rules of competition. Each company has 3 minutes to present. The jury has 2 minutes to ask questions. And I will have to stop you when time runs out, I'm afraid. Okay? So let's welcome our first contestant, William Fitzhugh, co-founder and CEO of Adden Energy. Welcome. Good luck. Maybe you have 3 minutes, sir.
Good morning, everybody. It is such an honor to be here with you today. My name is Will Fitzhugh. I'm one of the co-founders and the CEO of Adden Energy. We are developing next-generation solid-state batteries that will finally make electric vehicles accessible to everybody. Today, practical electric vehicle ownership is largely restricted to those market segments that have dedicated at-home charging options available to them, largely in the form of either a garage or a carport. This has been an excellent early adopter segment for electric vehicles, but as we aim to electrify the general population, say 50% or more electrified, this will quickly become a limiting factor. For example, in the United States, 37% of Americans live in housing units that lack garages or carports. So at-home charging is impossible. Here in Europe, the numbers are even higher. For example, here in Spain, 55% of Spaniards don't have garages or carports. Adden Energy's vision is to enable everybody to electrify by making battery charging as fast as gasoline so that everybody can recharge using public infrastructure with minimal impact to their daily routine. To this end, I am extremely proud to introduce Adden Energy's lithium metal batteries for the first time here at Energy Tech Summit. This is the world's fastest charging lithium metal battery. It can fully charge in less than 10 minutes. And at that very high charge rate, it lasts over 5,000 cycles. So we have 10x advantages over the competition in terms of both charge rate and cycle lifetime. These metrics are exceptionally important to the automotive OEMs. Adden Energy is on track to deliver pre-A samples, these exact cells, to 10 global auto OEMs this year, including 4 in Europe. And we are on track to deliver our first A sample by 2026. I am very humbled to work alongside a world-class leadership team at Adden Energy, and we're very thankful to our development partners who have made this possible, including Harvard University, where the technology was originally developed, and our funding partners, both within the United States government and our equity investors. I'd love to answer any questions you have. To any European VCs in the audience, we are currently raising and have a slot that we would really like to fill with a European VC because growth in Europe is going to be so important for our go-to-market strategy. I know it was really short, but that's a 3-minute pitch. Happy to answer any questions you have.
Thank you very much. Jury, you have 2 minutes for questions.
Thank you. Very impressive. Are you looking to build your own manufacturing? Are you going to be a licensing model? Are you going to be, I'm trying to understand what's the future capital uses, I guess, and intensity.
Yes, it's a very good question. So these cells are fully manufactured on lithium-ion production equipment. So everything we use today is all lithium-ion production equipment. We aim to be a full cell manufacturer, so leverage existing infrastructure to manufacture the cells ourselves. We are potentially open to working with established cell manufacturers to get to market sooner, but the big fish is to be the full cell manufacturer, so we're going to continue to pursue that, and if an earlier avenue becomes available to us, we'll take it.
Could you expand
The question was, could I expand a little bit on our go-to-market strategy? So the gatekeepers here are the automotive OEMs. It's a long road to getting cells into automotive hands. We are now working with, as I mentioned, 10 different global OEMs, including 4 in Europe, on what we call pre-A samples. So the end of that engagement would be a joint development agreement, and then we start developing A samples with them for one of their particular product lines. So currently, we are working with their engineering teams to see which of their in-house projects, when they're going to come to market, what the technical requirements are, so that we can focus our cell developments along those ends. We anticipate generating revenue next year with our first paid samples, and then full production 2028.
What about the energy density compared to other battery technologies?
So, question was on our energy density. We are lithium metal, so the energy density can be quite large, 400 plus watt hours per kilogram. The cells we're making now are just under 350 because we're really focused on our competitive advantage in charge rate and lifetime, but we can go higher.
Thank you very much. Next up, we have Rutger van Ralten, Francisco Morone, co-founder and CEO of Alchemio. Remember, you have 3 minutes. Okay. Good luck.
Okay, hi everyone. I am Francisco. I am CEO and co-founder of Alchemio. We know that the energy transition is driving this incremental growth on the metal industry, and that we are facing a big shortage in the supply of critical minerals. The big problem here is that while we have all these decentralized feedstock sources that come from mining, tailings, or even recycling, we must ship all these materials to huge centralized refining facilities that are mainly located in China. So at Alchemio, we have this clear vision on decentralizing the refining market by collocating our modular and low-cost technology in the same place our feedstock is coming. So in this way, we not only can reduce the transportation fees and the green gas emissions, but also we can increase the revenue for both parties. We have a 3-stage process. In the first stage is a bioleaching with organic acids that are produced by our own microorganisms. And the second stage, and here is our secret sauce, is that we develop this molecular complex that is capable of selectively attracting the metals that we intend to extract, for example, lithium or neodymium. And then we applied a magnetic field for making a super efficient and fast extraction. We have a team of second-time founders, but we also complement this team with experts in chemistries, engineers, and microbiologists, and we are currently working with 3 special consultants that are experts in the different fields of our innovations. This team already validated our proof of concept at lab scale with high efficiencies in the different stages of the process. We have 2 LOIs signed, and recently we are working with 2 key mining companies of rare earth elements from Brazil that they want to test our technology with their sources. In the next following month, we will be filing our first patent, and we have this vision of creating a portfolio of affinity molecules for each metal that we will be extracting. And as we visualize or have the vision of decentralize the market, we have 2 big pillars in our business model. The first one is building integrated refinery plants in joint venture with different miners or recyclers around the world by collocating our modular technology in situ. And the huge ambition is to license our technology as a product to third-party refiners around the world or miners that want to make this closed-loop model using Alchemio's technology. Thank you very much.
You have 2 minutes for questions.
Thank you very much. Esha Lipman from Extantia Capital. So in raw materials, the play is about the cost. What do you think will be the cost per ton, let's say, for lithium or other metals that you can extract? And also, it would be really great to understand what's the energy consumption, if you have any, for the process.
Okay, regarding the cost, we are currently, our OPEX is $7 per kilogram of extract or processed metal. And the energy consumption, it's, I don't have the exact number, but it's super low because magnetism don't use energy and that. So.
different materials have you demonstrated this system on? Like, what different metals have you tried? And what's the kind of the purities that you're able to achieve?
Okay, our proof of concept, we did it with lithium. We have created this affinity molecule that is specific for the lithium extraction, and we reached 95% of the recovery. The next metals we are working on, it's neodymium and dysprosium, and the pipeline continue with cobalt, nickel, and manganese.
Could you please tell us a little bit more about the financing requirements, both in equity and maybe working capital or kind of like infrastructure financing?
Oh, sorry, can you...
The financing requirements, both in equity and then maybe also kind of like working capital or infrastructure financing. Are you planning to raise capital?
Yeah. Oh, sorry. Yeah. Well, we just got accepted in Berkeley's accelerator program, so this month we'll be focusing on the technology. And we are planning to raise our seed round of 1.5 million by the second or third Q of this year. Yeah.
Thank you very much.
Okay, thank you to all.
Next up, we have Rutger van Rauten, co-founder and CEO of CarbonX. Remember, you have 3 minutes. You're right.
Okay, day one took its toll on my voice, so bear with me for that. The demand for electric vehicles is growing, but raw material supply chains are falling behind. And if you take graphite, used as the electrode material for the anode, 95% of graphite is coming from China. And that creates a geopolitical dependency, which leaves the supply chain vulnerable to disruptions. With CarbonX, we actually decouple automotive and battery makers from the geopolitical dependency by creating a localized supply chain. And we do that with a patented emulsion feedstock technology that we combine with a 90-year-old process to make actually carbon black. So out comes a drop-in alternative for graphite, which can be replaced one-to-one. Currently, we have access to 40,000 tons per annum divided over Europe and US, which we basically do with our production partners owning the assets. The 40,000 tons per annum is representing supply to almost 20 gigawatt hours, basically 20 gigafactories. Not only do we provide security of supply locally, CarbonX is price competitive. And actually, because we're using a lower temperature process, which already produces the material in 3 milliseconds, we have a 5-time lower carbon footprint than synthetic graphite. We're the first team worldwide producing a graphite drop-in at this scale and at such price levels. And up to now, we have supplied 1,000 tons to cell makers and EV OEMs from 3 different sites globally, and the material qualifications are currently ongoing. Over the last 6 months, we've locked in 6 non-binding offtake agreements, representing a total value of almost 500 million euros supplied in 2030. As I said, material qualifications are ongoing to see how the material functions in each of the chemistries of our clients. So my name is Rutger van Rauten. We have raised 14 million euros so far to get to this scale. And I ask you to help us build a more resilient supply chain to make sure that Europe and the United States can actually source anode materials independently. Thank you.
Thank you. Jury, you have 2 minutes for your questions, please.
So you have raised already 40 million? And
14.
Oh, 14? Okay, so how much is going to be your next round, and how much of equity would you need to grow your business?
Yeah, thanks for your question. We've raised 14 million euros so far. We developed a technology for tire industry initially, so that's why we got to scale. Figuring out that sustainable tires is something that's not yet ready for the market. Our next plans are actually on securing a binding offtake agreement, preparing then for a Series A of around 40 million euros to build mixing sites in US and in Europe.
So, as you know, there are other folks that do do the drop-in for anode materials? Nano One, Sila, others. How do you compare it to some of the others in terms of down the line, the costs?
Yeah, thank you. The question is, there are many other drop-in solutions, some involving silicon with higher energy densities. I think our strength is in cost and supply. So we can fully supply the graphite that's being used today. We're also developing a track where we can incorporate silicon with dry mixing. So that's also a next generation type of product. On cost, we are cheaper than synthetic graphite. We're basically offering now on par with natural graphite from China. And these are cost levels most of the drop-ins cannot meet.
You've obviously made a lot of progress. Curious, so kudos. Curious, what sort of challenges do you see in the next sort of leg of the journey?
Okay, so the question is about the challenges for us in the near future. I think it was already mentioned, EV OEMs is usually taking a lot of time to get qualified. We're currently in B sample stage. The challenge, I think, is that with procurement, they're looking for graphite, and we're not substance identified as a graphite. We are a modified carbon black. So our challenge is basically in working with strategy, with tech, and with procurement at the same time. And that's quite challenging.
I have to stop you there, I'm afraid. Sorry. Thank you very much. Next up, we have Radovan Gallo, co-founder and CEO of Flux Aviation. Remember, you have 3 minutes, sir. Good luck.
Good morning. My name is Radovan Gallo, and I'm the co-founder and CEO of Flux Aviation. And my mission for today is to convince you that the future of flight is electric. As most industries are reducing their emissions on the journey to net zero, aviation is projected to nearly double its output between now and 2050. But as you can see, aviation emissions are not evenly distributed. The big spike on the left represents all short-haul domestic and regional flights. In fact, all journeys below 500-mile distance altogether account for 20% of all aviation emissions, which translates to over 200 million tons of CO2 annually. And that is what we set as our target, to electrify and decarbonize. Because this is part of our vision to build a more connected world where everyone has access to low-cost and zero-emission transportation options, giving them access to better education, better healthcare, and better career opportunities. To achieve this vision, we are developing electric propulsion systems that will revolutionize how we power airplanes. These are complete systems that include electric motors, batteries, and power electronics, all in one package that's designed to be retrofitted into a range of existing aircraft. This will make flying over 40% cheaper, dramatically quieter, while producing no emissions in flight. I'm a chartered aerospace engineer with experience from Formula One. In my previous startup, I was leading development of highly regulated medical devices. My co-founder, Neo, has spent years developing cutting-edge electric motors at Dyson. And we are starting by electrifying the training aircraft market. This category of aviation benefits heavily from very streamlined regulations, making it cheaper and quicker for us to bring new products to market. And it's allowing us to prove the technology, gain customer feedback, and work closely with regulatory agencies before scaling our technology to larger and more heavily regulated aircraft categories. Because like I said, our ultimate goal is to electrify and decarbonize all domestic and regional flights. This is currently the fastest growing segment of aviation, fueled by growing demand globally for direct point-to-point connections between smaller cities. As a company, we are moving incredibly quickly, which is virtually unheard of in traditional aerospace. In just the last 12 months, we have successfully tested our full-scale prototype system, and we have developed and patented our next-generation battery modules. We have also bought our own aircraft in September that we are now converting to electric power to act as our flying demonstrator. It's nearly finished and is scheduled to fly next month in May. But it's not just us that are excited to see it fly, because we are building a world where aircraft manufacturers have a choice to either continue fitting polluting combustion engines or switch to cheaper, quieter, and zero-emission electric power. And to make this a reality, we are now opening a seed round of £1.5 million that will allow us to launch a commercial product in the UK and in the European markets in the next 12 months. So join us to make the next revolution in aviation possible. Thank you.
Thank you very much. Jury, you have 2 minutes for questions.
Hi, Yasha Lipman from Extentia Capital. A very impressive and inspiring solution, but there are some other competitors that are slightly more advanced than you, like aviation or other, maybe even eVTOL, which is a bit different than what you're trying to develop. Do you think there is a room for such a solution, and how can you differentiate?
Yeah, absolutely. So we are not trying to compete with eVTOL companies like you mentioned because of the range and utility. eVTOL focuses on urban mobility, while conventional aircraft give you nearly double the range for the same battery capacity. So you can connect cities to cities, you can connect remote communities, and we're really fueled by existing demand because aircraft, they have a very long lifespan. They have typically 60, 70 year life cycle. So aircraft that are flying today will still be flying in 2060, 2070. By replacing the engines for electric zero-emission alternative, you can give them a new lease of life, continue flying. So rather than scrapping them completely and buying a whole new airframe, you can actually get a benefit from keeping existing aircraft flying.
How will you or your customers solve the challenge of charging? Because I guess there needs to be some fast charging, right? Because often, especially if you have the regional flights, the planes are taking off half an hour later.
Yeah, absolutely. So for the training aircraft fleet, the charging problem is not as big because most local airfields and small airfields where flying schools operate, they already have three-phase power, so they're ready to install a proper charging point. In terms of commercial aircraft and having the 30-minute turnaround that all the airlines really want, there is already a megawatt charging standard that's being implemented as a solution both for like HGVs, marine, and even aerospace applications. And recently, last year, we visited Sweden, where they actually installed one of these chargers at the airfield, and it cost 300,000 euros and was a 6-month project. So it's not a huge expense in terms of capital expenditure compared to switching to something like hydrogen, for example.
Thank you very much.
Thank you.
Next up, we have James Eaton, the CEO and co-founder of Ionetic. That's right. You have 3 minutes, sir. Good luck.
Hi, everyone. I'm James. I'm the CEO and co-founder at Ionetic, and I'm going to tell you how we deliver a 90% saving in the development of automotive battery packs. First thing you need to know is actually 2 groups of car companies in the world. You can't collect them all in one. There are niche vehicle companies, buses, trucks, supercars, the things that drive around airports. Loads of them in the world, but they don't make very many vehicles. They have very small vehicle development budgets, but quite low sensitivity to unit cost. All of this is opposite for all the car companies you think about most. They have loads of money to develop new vehicles, but high sensitivity to unit cost. The problem, everything's set up for them. If you want to electrify this, it's fine. You spend $50 million, good to go. They don't have $50 million. Leads to quotes like this. We don't see any way to electrify our vehicles with what's available on the market. So we need to make it cheaper. We need to make it 10 times cheaper. And here's how we do that. We're a one-stop shop for battery pack design, test, and manufacture. We take inputs from our customers like energy, power, mass, cost, and we take engineering inputs, materials, geometries, adhesives, and we feed that into our platform where we combine all these things in software and hardware so we can do lots of different battery packs. So in the design phase, now what we're doing is we're taking the hardware and we're scaling it to whatever shape you want it to be. In testing, we can now reduce this by 80%. Just do 80% less testing, it's all still fine. And then in manufacturing, we can do really flexible manufacturing systems, build all these battery packs on the same manufacturing line, reducing the CapEx massively. And when you do this, you can do 10 times cheaper development cost. Now costs 4 million instead of 40, and actually give customers a route to market. So our route to market, we start this year, we're going to deploy our prototype production capability, next year's first full WAC production line, and then we'll scale to over 200 million in revenue and 1 gigawatt hour of production in 2027. We have an incredible team. I have 6 years experience designing battery packs. Andy Palmer, our chairman, former CEO of Aston Martin and COO of Nissan. Stephen set up JLR's Gigafactory, $250 million setup there. And we have our first main customer, Alexander Dennis. That's me, stood in front of one of their buses. We're doing a $750,000 development program to unlock their battery order, which I've not put on here, but it's hundreds of millions of pounds. We also have more in the pipeline as well. Total addressable market, $32 billion. So in 2030, we're going to do 800 million in revenue. And we're raising 6 million. We're going to do this, onboard more customers, get 10 Alexander Dennis's, and you're doing $1 billion in revenue a year. deploy our first prototype production facility, and grow our team and capability. We're doing all this to turn Ionetic in the go-to for battery pack design and manufacture. Hopefully that was enough of a teaser for you to come and speak to me after this. You scan that QR code, email me, come and grab me, and 3 seconds left. Thanks.
Thank you. Jury, you have 2 minutes for your questions.
Yeah, Tommaso Darigi from Neuron. What's the sample state advancement of your commercial conversation and all the other 3 customers that you mentioned? And what's your go-to-market? Because that's a quite specific one for...
Yeah, so
what you're targeting.
Alexander Dennis, world's largest double-decker bus manufacturer. We're literally designing their next-generation battery pack now. Like, we're getting paid for that. We're 4 months into that. That'll take about 10 more months. After that, they place an order, offtake agreement, and kind of off from there. We have 4 other really advanced customers. They've all indicated they want to go ahead. It's just now working out the commercial and technical terms on that.
Sample A, sample B, like...
Well, yeah, so that's an A sample,
okay.
The Alexander Dennis project. Okay. Then we'll do B and C in a further development program, and then hit SOP maybe 2026.
Only competitor, like there's no anybody else, like in the...
Well, so the others will start in A sample and go through as well. So it's normal automotive development cycle, yeah.
Thank you.
Hi, thanks. Could you talk about, I guess, the progress you've made in terms of product between design and manufacturing side of things?
Yeah. So we have battery packs. You can come and see them, touch them in our labs in London. I know that's probably quite easy for you if you want to come see them. Yeah, you can come and see them. They're real. I think we're about TRL 5 or 6, depending on how you want to categorize it. In about 9 months' time, we'll be TRL 8. So we're making pretty fast progress on that. But yeah, we've done several iterations of the prototype. We're just running our validation, our automotive DVP, on our own architecture at the moment, so we can validate, there's 10,000 design decisions in the battery pack. The architecture is like 8,000 of them. So we're validating those 8,000, and the remaining few, that's what allows us to tailor the battery solution to every customer, so you can have exactly what you need every time.
Thank you very much.
Thank you.
Thank you. Next up, we have Alex Kos-Jakov, CEO of Natrion Incorporated. Remember, sir, you have 3 minutes. Good luck.
Hello, everyone. My name is Alex Kos-Jakov, and I'm the co-founder and CEO of Natrion, a battery technology company based in the U.S. And we believe solid-state batteries are the future. In general, of course, these batteries are safer and much better performance than current lithium-ion. And really the problem is that we don't know how to manufacture them right now with current gigafactories. The science has been sound for a while. And so you take, for example, this is Northvolt's gigafactory that they're building out. Once it's done, it's going to be worth about $5 billion. And reconfiguring the processes and equipment towards solid-state battery assembly is going to cost almost as much as that original capital investment. So that's why at Natrion we've developed a material we call LISIC. This is a solid-state electrolyte separator that has complete compatibility with existing battery gigafactory processes. So you can drop this in on today's production lines, it doesn't matter the chemistry or the cell form factor, and start producing solid-state cells at high volumes and low costs. Now, LISIC's been validated in current generation lithium-ion chemistries as well as next generation lithium metal cells. And in particular, these lithium metal cells are exciting because it can enable manufacturers to make significant leaps in energy density as well as safety. So for example, our lithium metal cells have been demonstrated to not enter thermal runaway at temperatures as high as 250 Celsius, and all the while we're maintaining manufacturing cost parity at the cell level and actually enabling cost efficiencies at a battery pack level. We've been shipping out cells and the LISIC material by itself to OEMs for them to test and qualify and evaluate. And now we're at a point where really to do more, we need larger volumes of LISIC material. Hence why we're raising now to build our first full-size production line for the LISIC. It'll give us about 20 tons per annum, enough for 240 megawatt hours. And that'll get us through our factory floor integration pilots and to initial offtake agreements. How we're thinking about monetizing this is we can project that we can generate $33 million per gigawatt hour of cell manufacturing capacity that we service. So some of these larger gigafactories that are coming online can be quite significant on a per year basis as far as revenue that we can bring in. We are raising our Series A round for this production line build out where we're targeting 30 million. And I'm happy to provide more details on that to anybody interested. My last slide here is our team. So I started this company right out of college with my co-founder Thomas. We now have 20 total on our staff. The R&D is being led by Duke and Dashang, who have over 40 years of experience in electrochemical device development. And our process scale-up is being led by Krishna, who was at Corning for 11 years, part of the team that developed Gorilla Glass. He was at QuantumScape. He was even chief data scientist for the state of Illinois. So thank you very much for listening, and happy to answer any questions.
Thank you. Jury, you have 2 minutes for questions, please.
Hey, Alex, thank you for this. Can you talk about, you mentioned that the process of integrating into existing manufacturing is relatively straightforward. What is that process? I mean, how does a gigafactory set up in Northvolt or someone else actually integrate your solid state separators?
Yeah, great question. So lithium-ion cells right now that are using liquid electrolyte have a polyolefin or similar type separator. And so it's really, we're substituting the role with our separator, except our separator is a fully dense solid state electrolyte, but we have the same flexibility. We're typically in the same range of thickness and same mechanical strength and so forth. That's why the equipment can stay the same.
Jury, any more questions for this young man?
Okay, thank you very much.
Thank you very much.
Yeah.
Now it's time for Anastasia Kuskova, the CEO and founder of Sirius. Remember, you have 3 minutes. Good luck.
Fossil fuel economy is powered by fossil fuels. Green economy is powered by metals. That is why metal companies today are under immense pressure to become greener. I'm a former chief sustainability officer in a multi-billion-dollar metal and battery producer. And you might think that my day looked like this. But actually, it looked like this. Or this. Or this. In fact, sustainability teams in the metal companies and the metal supply chain spend more than 75% of their time on managing ESG data. And this is not how we achieve green metals for the net zero. That is why we built Sirius. With Sirius, we are creating an AI-powered sustainability data infrastructure for metal and battery value chain. So companies are empowered by data, not drowning in it. Here's how it works. First, our algorithm captures data from various sources and builds a unique sustainability twin for a mining or metal company. Then, using this twin, companies across the supply chain can easily access or share information in any format. Then, our algorithm finds trends, identifies stakeholder priorities, and helps teams focus on what really matters. In just 15 months, we won as clients leading industry giants, together covering more than 11% of battery metal market. But for us, this is just the beginning. Our vision is to become a connective tissue for the entire industry. Something wrong with the graph. Yes, there should be a circle. Connective tissue for the entire industry, linking the twins to the metal exchanges, banks, and verifiers. And we have just the right team to make it happen. Together, we have more than 20 years of experience in the metal and battery value chain, and we have known each other for many years. I'm a former sustainability officer, and I built a battery traceability startup together with Tesla. Sergey is a Boston Consulting Group alumnus and a former executive in metal industry. And Seva is our data guru, and he actually built one of the top supercomputers before. And together, we will empower green transition of the battery value chain. So let's get serious.
Thank you. Jury, you have 2 minutes for your questions.
Why would you need a digital twin to get the data? Why can't you just take it from the hardware?
Come again, please?
Why would you need a digital twin to actually extract the data? Why can't you just extract the data from the hardware or from like local operation and then bring it to the cloud?
No, that's exactly what we do. So we just call it sustainability twin, so that when we communicate, it's clear that this is like a sustainability database, a unique digital profile. So it works like a single sign-on on Google that you like you do. We just call it a twin because it captures the data and it has a very good mental image for the clients.
Okay.
So
okay.
yeah,
Thank you.
it's not really a digital twin of the site, etc. Yeah.
Thank you for your pitch. Can you please elaborate about the business model and what you think you can leverage from each customer?
Absolutely. So what's our business model? So we are SaaS, which is strange in this lineup. But so we are SaaS, and we charge by the number of queries to the twin. So usually on our typical clients, it's in thousands. For some, it's 1-2 thousands. For some, it's tens, because they receive a lot of requests from the entire supply chain, from customers, customers of their customers, customers of their customers of their customers, etc. And also now banks and any other stakeholders. So yeah.
And you're not planning to monetize the demand side?
Yes, we're already working with some OEMs so that they can access twins of their metal suppliers. And with metal exchanges, we're building with several key metal exchanges for with the same approach. So yeah, both sides. Ideal case, everybody pays. So.
Thank you. Could you talk about your data acquisition strategy and how you make sure that everything is accurate?
Yeah, so what's our data acquisition strategy and how we make sure that everything is accurate? So we definitely come to the companies that are already quite mature, so they have to measure. We don't measure. We have collaboration with some measurement companies, but we don't measure. So first they have to have some data, and then we, during onboarding, we create like a decision tree on which data, just finish the answering quickly, so that we identify decision tree, what data we should count as primary, and on which to rely on if there is a conflict in data, which is quite a common case.
Thank you. Next up, Saina Trufat, Chief Commercial Officer at Swoby. Remember, you have 3 minutes. Good luck.
Hi, everybody. It's great to be here. My name is Sina, CCO at Swoby. We are a provider of battery swapping stations that can charge different kinds of batteries all within one station. We work with logistics and mobility companies to help them lower the cost of operations while ensuring that charging does not lead to fires. Founded in 2020 out of Berlin, we now operate in 9 countries. We just launched in the US, which is very exciting, and we have the safest product on the market. We work with more than 50 great customers, charging a total of more than 20,000 batteries. So we have all these stations, but what's the actual problem we're solving? The big problem of micromobility is the cost of operations. You have to imagine vans driving in and out of cities every day, transporting batteries to be charged at warehouses outside of town, and then be redeployed with the vehicles in city centers. We know that this cost eats up a large chunk of the revenue from a delivered parcel or a scooter ride, with the cost of labor being the major cost driver. Our solution to this problem is the Swoby network, a network of battery swapping stations allowing users to swap their batteries on the go while we take care of charging. Our network is accompanied by a software solution providing an open API and valuable insights into the battery pool and operations. Now going one level deeper, how exactly are we solving the problem? I'm highlighting 2 use cases here, starting with Voi, one of the largest micromobility providers in Europe and a user of Swoby's infrastructure. Now Voi is faced with the need of having to drastically cut the cost per battery swap. And one way to do so is to increase the battery swapping capacity per hour while keeping costs constant. With our network, Voice employees can start their shift directly at the Swabi locations in the city center instead of having to drive in from a warehouse outside of town. This not only saves them 20% in costs, it also ensures charging safety 24/7. The second use group I'll highlight are delivery workers in cities like New York. These people drive 160 kilometers a day. They pay $100, $150 a month to charge their batteries in e-bike shops or garages, and they often carry heavy spare batteries with them to fulfill their shift. With our battery subscription service, they get access to all the stations in the city, a free upgrade to our battery, and unlimited swaps for $2 a day. And the city is happy because e-bike charging just got safer. I'd love to tell you more, but if I can leave one thing with you, it's that we've only just begun. And as developing and emerging markets adopt electric two-wheelers at scale, charging is where we really can make a difference to make energy clean, accessible, and affordable. We are raising right now. We're also looking for partners, so please grab me at the coffee shop or get in touch with me on LinkedIn. Thank you.
Thank you. Jury, you have 2 minutes for questions, please.
How do you see like the ban of several e-scooters in Europe, right? Especially like Paris was the first one, but it's falling without it.
Yeah, that has definitely affected our customer base, but we see it as a positive thing that now demand is kind of consolidating, and you have a couple of winners emerging from this industry. After Bird's bankruptcy and other players leaving the market, we actually see that there is a stable demand for those mobility rights, and there are a couple of winners emerging with whom we're lucky to work, such as Lime, Voi, and the likes.
But the station is the same for e-scooters and e-bikes, or is it a different one?
Yeah, we see that e-bikes are a bit less regulated because cities often favor them over kick scooters because people still move a little bit. It's sort of sporty still. But that's definitely something that is going to continue to be active in Europe. The good thing is we do not only rely on revenue from, let's say, the transportation of people, but also transportation of goods. So we work with lots of companies in logistics as well who don't see their licenses to operate threatened.
Do most of your customers own the batteries, or do you own the batteries? And if you own some, I guess with the delivery drivers you do, how do you finance this?
Yeah, good question. So indeed, we operate two models. We have a network of private stations, such as the ones Voi is using, and in that case, they come in with their own batteries. We don't interfere there. But indeed, for the delivery drivers, we own the batteries, so we're sitting on those assets. We have a SPV for that, so we use that financing to purchase those assets, working with banks, and that has been working really well.
Thank you very much. Thank you very much. Thank you. And thank you. Next one up, David Outsanji, co-founder and CEO of Wolfgang. You have 3 minutes, sir. Good luck.
Thanks a lot. So now you can relax. I'm the last one, and I'm just telling you how we overcome the climate crisis. And actually, we just need to tackle the biggest polluters in the world. And that's the energy and the industrial sector. And the industrial sector is easy to decarbonize, to be honest. We just put on every company a solar panel, we electrify their cars, and then we just, in order to use the sun energy in the night for the EV cars, we need battery storage systems. But why is not everybody doing it? First of all, batteries are expensive. Then, they are not sustainable, and they are not available right now. So we come with the idea of just reusing electric vehicles after their first life on the street, requalifying them, and putting them into an amazing stationary storage system. But to enable second life, you need to have some secret sauces. So first of all, everybody needs to know that you are the one premium and sustainable battery storage provider. Then you need to have direct contracts with the automotive OEMs to get the supply. Therefore, you have the brand awareness. Then you need to also outperform the automotive testing by having proprietary testing facilities. And built an amazing battery storage system, which you can take for an Aldi store or also for grid scale opportunities. Therefore, you have the technical advantage. And then you need to get into the market and make the batteries as profitable as possible. And that's possible with a smart energy management system. And in a combination with our European partner network, which are selling and deploying local batteries for us, there we also have our sales advantage. But that's actually really theoretically. So we are already doing it. Just in the last, like in Q4 last year, we made roughly 2 million in revenue. And in the production we are currently, we can go up to over 20 million. And that with an amazing margin. So we also hired all the people we need to now scale up really quickly. We secured the battery supply. We scaled up our production and also our tech proven. And just last month, we had the best Voltfang sales months in our history. Now, we are raising 8 million to become the one player in the energy market. And to be honest, we don't have so much time to overcome the climate crisis. So now we need to invest into the executors. And we are the ones who are executing. We are the ones who are building an energy provider who is there with sustainable batteries. If you want to know more, you can also read our impact report. Thank you very much.
Thank you. Jury, you have 2 minutes for your questions.
Actually, we don't actually need so much capex. So in the end, in the current production, we are with 1,200 square meters. We invested roughly 200K and are able to make over 20 million in revenue. If we scale it up a little bit more, we have a gigafactory. So in the end, our capex need is de minimis in order to our revenues, to be honest. People to say that we have 6 production employees right now who are making like this kind of revenues, and we see that also automation will help us to grow really, scale it up really quickly without the labor need, to be honest.
What is the lifespan of each one of those units? Each one of these batteries inside a unit need to be in the same kind of state, or it can be multiple changes?
So they need to be roughly the same. Therefore, we have the proprietary testing in front of it, so we can grade them together. But to be honest, currently the batches are nearly same graded. So therefore, we can use this from the same batches for different kind of storage systems. But yeah, they need to be roughly in the same grading. But that's actually also the same case with new batteries, because they have also some differences. So our proprietary testing system, which we always set as an inbound, helps us also in the production to put them into the batches.
Thank you.
Hi. Masaki Ano from EI. Can you talk a little bit about your feedstock? There's many different countries in your companies in your business.
Yeah.
Are you already using Second Life, or is it like a B grade First Life?
So currently we have most of our batteries come from second use, so overproduction batteries, which can also be supplied over the next 3 years. We already got our Second Life batteries, and we see that in the next 3 to 5 years, a huge batch of batteries will come back, and then we are prepared with the whole data we are generating currently for the Second Life stock as well, and the battery prices will also decrease at that time. So currently we have a lot of Second Life, second use batteries, but the future will be Second Life.
Many thanks.
Thank you.
Thank you very much. A big thanks to presenters and our wonderful jury. A very productive round, I'm sure you'll agree. We'll have our third track at 12 o'clock, so you have a very small break to come back to some more amazing startups. Thank you very much.